this next part, we are talking about these three different relationships between two lines. Okay, so first, two lines can be parallel as long as you observe that the direction vectors are scalar multiple. So remember what is scalar multiple in vectors 1, or k times of d, of another. Okay, and that they must not go through the same point. Okay, they must not go through the same point. If they go through the same point, then then they will be on top of each other, right? Because, so for example, this one, okay, I have the first line, which is a point 1 minus 1 minus 2, okay, plus a direction of 1, negative 2, negative 4. You see how I draw the line? It's always straight this way with a point and a direction, okay? Then I have another line, okay? It doesn't matter how the line look exactly, okay, as long as you understand the relationship, okay? It cuts another point. Now, this point may not be vertically here, okay, maybe it's over here. 5, 4, 0, plus a direction vector of 3 minus 6 minus 12. Also, I noticed that D2, right, is 3, negative 6, negative 12 is equals to 3 times of 1 minus 2 minus 4. You can factorize out negative sometimes also, it doesn't matter. As negative just means that the direction is opposite, but it doesn't matter, okay? Oh, this is the 3 times of D1. Okay, so since D2 is equals to 3 times of D1, then L1 have to be parallel to L2. And of course, you must observe that these 2 points are must not be the same. Okay, even if they are a multiple of the same is actually okay. Okay, but usually they will not give you the same line on top of each other. Okay. Second, okay, what happens if two lines intersect? Okay, so if they intersect, right, first the direction and the other direction, right, they are not going to be the same. Okay, so you can observe that, this is D1 and then this is D2. They are not the same. Okay, so first you say that D1 not equals to D2, so they are not parallel. Okay, so now if they are not parallel, then they have to intersect, or they could be skewed. Skewed is going to be the third part. So how to see whether they intersect, or the question show that it intersects exactly one point. The first one is r equals to 1 minus 1, 3 plus lambda 1 minus 1, 1. Okay, the other line is r equals to 2, 4, 6 plus mu times of 2, 1, 3. Okay, so you see this is r and this is r. We have to solve it simultaneous equation, but how to equate them? All the r's are always the same. You can always put it in, okay? And before we put it in, let's put it together like this. 1 plus lambda minus 1 minus lambda, as well as 3 plus lambda. Okay? Then the other one would be 2 plus 2 mu, 4 plus mu, as well as 6 plus 3 mu. Okay? Yeah, in order to find the point of intersection, it's like solving simultaneous equation. I say that 1 plus lambda minus 1 minus lambda and 3 plus lambda is equals to 2 plus 2 mu, 4 plus mu, as well as 6 plus 3 mu. So our job is to form a system of equation. Okay, so lambda and mu on one side, 2 mu minus lambda equals to negative 1, or you can do it the other way around, doesn't matter. Okay, mu plus lambda equals to negative 5, and then 3 mu minus lambda equals to negative 3. Okay, input this into your GC, so you can say that, from GC, so mu is the x, lambda is the y. You see how I arrange it nicely so that I will not get careless. Okay, so put it into your GC, go to your apps, okay, simultaneous equation solver, and then, number 2, okay, I have 3 equation, 2 unknown, which is a good thing for you. Okay, 3 equation, 2 unknown, and then I press next, mu, okay, minus lambda equal negative 1. Mu plus lambda equal negative 5. Okay, as well as mu, I think okay, there's a 2 and there's a 3 here, be careful. Okay, so let's make it correctly, equals to negative 3. Let me just make sure it's correct, 3, and then the first equation is going to be 2. Let me just check, minus 1 equals to negative 1, 1 plus 1 equals to negative 5, 3 minus 1 equals to negative 3, and then I press solve. I'm going to get mu equals to negative 2, lambda equals to negative 3. Okay, so be careful. You get a unique solution, that's very good. Now sub back into either one of them. Okay, so the point of intersection is equals to either sub back the mu or lambda. So you sub back the lambda, 1 minus 3, that's negative 2. Okay, and then this is 2, and then this is 0. Okay, basically I'm just taking this and putting into here. Okay, and that's the point of intersection. You can put mu into the other one, you should get exactly the same answer. Okay, so two lines can either be parallel if the direction vector is a multiple of each other, or they will intersect, okay, at a point if you can solve simultaneously using GC to get a unique solution. Okay, and of course the last one is because in a three-dimensional space, right, a line can be on top of another and they will not meet, okay, because we are in a three-dimensional space. Can you remember? This is X, this is Y, and this is Z. Okay? Yeah. Now we're just going to do the same thing. Okay? So first, again, you have to say that D1 not equals to D2, so therefore not parallel. Okay? So because when they are parallel, they also will not meet one. Right? Then you can just quickly minus 1 minus 2 lambda, 1 plus 2 lambda, and 3 plus lambda is equals to 1 plus 3 mu, 3 plus mu, as well as 2 plus 6 mu. Okay, do the same into your GC, okay, form the three equation, put it into GC, and then you know that the GC, right, is going to give you there's no solution. Okay, because there is not going to be a unique lambda or mu that can satisfy this. Okay, so when you see no solution, what does it mean? Okay, so L1 and L2 are skewed. Okay, so they do not intersect each other at all because there is no lambda and mu that can satisfy these three equations. Yeah, so these are the three cases, okay, of lines, a relationship of the lines and whether they meet or do not meet, and if they meet, okay, we just need to equate both lines together, form three equations and use the GC to solve.